Okay, now there are possible types of solutions for the points of intersection of a circle and a line. So figure 4, it illustrates the possible solution sets for a system of equations involving a circle and a line. There's no solution if the line does not intersect the circle. There's one solution if the line is tangent to the circle and intersects the circle at exactly one point. And there's two solutions where the line crosses the circle and intersects it at 2 points. Now, given a system of equations containing a line and a circle, we want to find the solution. Step 1, we're going to solve the linear equation for one of the variables. Step 2, we're going to substitute the expression obtained in step 1 into the equation for the circle. Step 3, we're going to solve for the remaining variable. And step 4, we're going to check your solutions in both equations. So example number 2, we're going to find the intersection of the given circle and the given line by substitution. So equation 1 is the equation of the circle, which is x squared plus y squared equals 5. Equation 2 is the line, y equals 3x minus 5. So one of the equations has already been solved for y. So we can substitute y equals 3x minus 5 into the equation for the circle. So here's our equation for the circle, x squared plus y squared equals 5. And we can plug in 3x minus 5 in for y and then square it. So we have x squared, and when we square 3x minus 5, that means we have a perfect squared trinomial, or we can FOIL that, which would give us plus 9x squared minus 30x plus 25 is equal to 5. And then our goal is to set this equal to 0. So if we combine x squared plus 9 squared, that gives us 10x squared minus 30x. And if we subtract 5 to both sides, we get plus 20, which is equal to 0. And so now what we want to do is we want to factor and solve for x. So in this equation, they have a common factor of 10. So we can factor out a 10. So we have 10 times the product x squared minus 3x plus 2. Now what we can do is we can divide both sides by 10, since this is just a constant, a number. And if we divide by 10 on both sides, 0 divided by 10 is 0. So now we only have left is this quadratic formula, this quadratic equation, which is x squared minus 3x plus 2. So when we factor that, we get x minus 2 times x minus 1, and that's equal to 0. So solving for x for both of them, we get x is equal to 2, or x is equal to 1. And now what we're going to do is we're going to substitute the two values into the original linear equation to solve for y. So when x is equal to 2, we're going to plug it in equation 2. So y is going to equal 3 times 2 minus 5, and 6 minus 5 is going to equal 1. So the value for x in this ordered pair is 2, and the value for y is 1. And then we're going to take our other value for x, which is equal to 1, and again plug it in equation 2, which is the linear equation. So y is going to equal 3 times 1 minus 5. So 3 minus 5 gives you negative 2. So the value of the x-coordinate is 1, and the value of the y-coordinate is negative 2. So the line is going to intersect the circle at 2, 1, and 1, negative 2, which can be verified by substituting these points values into both of the original equations. So here's our circle in red, which is x squared plus y squared equals 5. And when we draw that linear line, we can see that it's going to intersect at those 2 points that we just solved for. 2, 1, and 1, negative 2.